All right, welcome to part two. I just recovered from a pretty big system crash, so I believe I have all of my settings back to the way they were, but we're starting our light build here. So you'll see it kind of hung at 0% for a minute, but now it's cranking along. If we didn't merge all of our windows, all of our mullions together, it would probably take at least an hour to do everything, but since we have that light mass importance volume, and since we did merge as much as we could, we even got the skylights together too. So since we got all of that, it's much, much quicker. So while that's chugging along, let's go through some cool techniques here. So by default, we're in lit mode, and we can see exactly what it looks like with the color and the lighting. If we switch to unlit mode, this is what the scene would look like if everything was ignoring lighting entirely. So we can kind of see this wall is a very aggressive yellow, so we know going forward we're going to have to turn that down. This red is way too saturated. I'm not a fan of how that is so matchy. It's important to see here all of the saturation values that we have and the brightness of the scene. Notice too that the ceiling is entirely white. No, thank you. So we'll skip over wireframe. That's pretty obvious. Detail lighting. This shows us reflections as well as static, baked, and dynamic lighting at the same time. So you can see we have the shadows and everything casting through the wall with the dynamic lighting that is currently being baked. But we also get all of the reflective properties, so you can see that there. But if we switch down to lighting only, we can see without those reflections what the scene would look like. So this is how you would get that sort of clay look that so many people like for their renders. And notice too that it's ignoring the transparent glass, which certainly helps quite a bit. Lastly, I'd like to go down to optimization view modes and go to your light map density, or Alt 0 on your keyboard. So by default, you usually want this to look bluish green, maybe like this color, but red is a big no-no. This is explaining the density and the complexity of our light map UVs that we have for each object. So this is a much more dense light map UV than, say, this. You'll notice the squares are entirely different sizes. And this, on the other hand, this floor extends the entire floor. What we would like to do for optimization is maybe cut it into parts. So you have here to here, here to here, and so on. I mean, this is huge. So let's pop open this mesh. If you double click that here, we can see what exactly I'm talking about. What is a UV? That would be a good place to start. So here's just that single mesh. When we apply a material to something, it's looking for a 2D image, which was referred to as a UV. And by default, we have this UV channel 0. As long as there's something here, you're good. Don't worry that it's red and white and all messy. But as long as there's something there and the scale of it is consistent, your mesh will have ooh, that's garbage, a clean material channel. So I'm not sure why it gave us UV channel 1 as well as 2, but UV channel 2 is what's being used for the lighting. And you'll see these shapes actually correlate to each individual face of our mesh. So this could be the top, that would be the bottom, and these would be the sides. Like maybe that is this long side here, but every individual face is accounted for here. And when we're doing our light building here, it's currently 98%. It's looking at that UV texture for the lighting for every single mesh and then casting light and seeing how the light and the shadow would work for every single pixel of this. And remember when we imported our Datasmith file, it asked us the minimum and maximum light map resolution size. The lowest we would ever want to go, unless we want to get crazy, is 64, which means it would be 64 pixels across here and 64 pixels vertically. This, on the other hand, is, if we scroll down here, this is 128 light map resolution, so we have 128 pixels across and 128 pixels down. And what that means is that all of these, I mean, this could be, what, 80 pixels here, and then 80 here, something like that. So if we wanted to optimize this further, what we would do, and we'll do this here in a bit, is we'll bring this into 3ds Max, maybe even get rid of this bottom half entirely. We don't need to light some of those sides that we'll never see. And then we'd actually break this into multiple objects. So we're saying trim it here, maybe break it here, and then here and here. So then we'd have this one square here would take up as much of that resolution as possible. We have a lot of empty space over here. We could make much more use of it. So let's close out of that, and you can see what I mean here. Those pixels that we were talking about correlate to those squares there. If anyone, I've had quite a time trying to dig up as much information as possible about UVs and how they translate in Unreal. If anyone has better information, please share it with me. I would love to learn more about it. So important to know too that the higher that is and the more red it is, the longer it takes for your light map. And before we had Datasmith to work with, we had to go into 3ds Max and unwrap every single UV for every single mesh. Datasmith does it automatically. It makes it nice and clean. We can see here, first of all, we have all of these errors. Let's not worry about those quite yet. I know it's a cardinal sin. Treat warnings like errors and errors like sins and all, but we'll ignore that for now. We'll just switch to our lit mode. We can kind of see what we got with our light bake here. So we got plenty of shadows. You can actually see it's much more bright in here. It's much cleaner lighting. This yellow stands out, and it actually lights the rest of the scene. You can see the light shines across, and then it bounces and reflects all of that color value across everything else. We'll notice too, our floor looks very, very chunky. That is a directly related problem to the to our density here. If we had this at a reddish value or broken into multiple parts, we would not have that. Furthermore, we don't get nice contact shadows here from our chairs and our furniture. We'll fix that. We'll get around to it. You'll notice too that compared to that, we have nicer shadows on this. That was one of those red objects that we had. This furniture, that has some problems. You can see some jagged shadows there. We can fix that. And then if we look at our lampshades here, this is actually very nice. I do like how you see that illumination inside, but I would like to make it more transparent on the inside so that we can actually shine light through the lampshade so it would be more realistic. If we look over here at our lights on the wall, we have some pretty big problems. We see this whole thing is just completely illuminated. It's white and 100% shine, so that's a bit of a problem. I really like how the skylights cast those shadows on the wall, as much as I hate what those shadows look like. And then if we look out here, we have the sun shining and casting shadows out here. We didn't get those trees that we noticed in Revit. You'll notice in Revit we also had silhouettes for people standing in here as well. I'm not sure why. If we were to export from Revit as a DWG file, we would retain that information. But I believe because Revit is recognizing those as completely 2D objects, that those did not have any 3D depth, so we did not get those in here. We'll not worry about that right now. If we really, really wanted them, we could go back into Revit, kick out another file, and import that DWG. Let's look at our cafeteria here. All of these tables, these are identical meshes, more or less. We have some problems with the complexity here. So the chairs look pretty good. We have those very red. We'll probably ultimately turn that down, but these are not receiving much lighting, and it looks like they're actually getting some artifacting due to this mesh here on the inside. Maybe it goes all the way up, and then it's causing internal shadows and a bunch of garbage in there. But we'll get around to it. Man, I even lost my bookmarks. Go back up here. All right. One more thing that I noticed too, all of these lights up here, when we had these configured, it gave us point lights in each. And what we would actually like is to be a light that extends across and casts down. And would it? It would not also cast up, so we could just make it one long beam that would then cast down vertically. Right now, it's just localized, and it's one big point that's illuminating both sides of that mesh. We don't like that. We'll fix that. Cool. Looks like we got a lot of work to do. First things first, let's deal with some of those reflections. Those are those are kind of getting to me. So if we do a search in our world outliner here, search for reflection, we have one reflection going on. This was actually the this came in when we started the project, and we had that that nice sky that we started with. I'm just going to delete that, start fresh, and we'll go up here, just make sure to build reflection capture so we got nothing going on. So if we go back to our modes view, let's search for reflection. Planar reflections, let's get that out of the way first. These are essentially mirrors. If you were doing like a wall mirror, or I think you can use this for water. This works pretty well. You can do some pretty funky things with it. We're not going to use that. If you're using VR, you may want to ignore that entirely. As I understand it, box reflections are not very well supported with VR, so we'll stay away from those as much as we can for now. Let's stick with the basic sphere reflection captures. What this is doing here, let's turn down the influence radius. This is taking that point in 3D space and then casting reflections on every mesh that it touches. So you can see as we move that around, it's actually changing the way that it's casting reflection on a space. And if we move it up, change up the influence radius, you can see we can get a much more broad and less spherical look to it. So we'll do a few. Let's make it about 600 so it extends around both sides of this hallway. And we'll just drag that around. I'm holding Alt and left click and duplicating it, making a few of these. Let's get one over here. Get another one looking good, looking good. Now let's do one. Let's go down here to our minimal cafeteria. Cool. All right, 2, 1. There we go. So let's see. I'd like to get like a nice view of this furniture as we go forward. So I'm actually going to duplicate this, bring it in really close. We'll actually turn that down to about 200. Let's do 150. So we can get like a very nice view of this. Maybe we'll get like a nice render or something looking out here. Maybe it'll be like a spot for the interior designer to show off how those lamps look in this beautiful lobby. I don't know. So we'll get one more here. We'll make this very big. We'll make that about 5,000. Let's do 7,000. Basically, we want this to encapsulate the whole building. As we go forward, we're not going to get much further out here. We're not going to worry about high resolution reflections out there, but it does cast light, and we would have a significant break in the lighting if we did not have that. So we'll just make sure that's capturing the whole scene. And you'll notice too that if we move that around, it's not affecting the reflections here, because it's based there. There's a hierarchy for size. So if I were to duplicate this here, make that 80. It'll listen to the smallest reflections first. So if we have a really big reflection, it's not going to affect anything in our area up here that does not already have a reflection capture, because that one is so big. Let's get a smaller one on this wall here so we can see some light shining across. Oh. Dang, that's nice. Cool. Okay, so if we actually go up to our reflections view mode here, we can see what we're getting. We're getting a lot more information here. Before it was just a bunch of confusing stuff, but you can see the points that we're getting reflected onto each surface. So if we move that around, you can see exactly how it's attenuating and spreading around. This isn't a problem per se, but let's get another capture in that corner just to, yeah, okay. We should probably get one at the end of the hallway too. You can see where that big reflection is capturing all that lighting. Yeah, get that in there. Ooh, nice. All right. So we got our reflections in there. We'll go up here, do the drop down next to build, and choose build reflection captures. And we are good. We'll get into the materials for all that, get rid of the reflective stuff going on. Let's get what should we do next? Let's get some textures in here. Yeah, so I imported some textures already. Let's get rid of those. We don't want those quite yet. I'll show you how to go through and make your own. All right. So if you right-click in here in your content browser, go up and choose material, and we'll make a new material. We'll call this M_carpet. Cool. Now if we were to make a nice carpet chair, drag that out, you see you don't got anything. You got this world grid that'll default back to a black as soon as it compiles it. If you go in here, we can see everything that calculates the look of this material. So by default, this base color is 0, metallic is 0, specular is 0.5, roughness is 0.5 as well. Emissive is always 0. Normal, which is normal, describes the direction that light is bouncing off of an object. Simulates a 3D much easier. So I'm going to try to keep everything on one screen here. Let's just walk through some of the parameters for materials here. So if we right click here, you can see all of these different things you can use to calculate different aspects for your material. We're only going to worry about a few things here. So type in constant, which will give us one single constant value. And we'll plug that into our base color. And then if we scroll this around, we can do 0 to whatever we want. Let's set that to 1. And you'll see we get this white sort of reflective material. If we save it, it'll actually apply to the object out here. Now, most of these values only listen for 0 to 1. If you hold 1 on the keyboard and click, you can do a constant 1 value again. So let's do 10 and then plug that into our emissive color. And you'll see this is actually going to glow. If we did 200, you'll see it glow much brighter. But that'll listen to anything more than a 0 to 1 value. But base color, 0 to 1, metallic, specular, roughness, and so on. If we do a constant 3 value, constant 3, this will give us red, green, and blue. So if we plug that in here, and drop down that arrow there, we can do 0.5, 0.2, and then 1. And it'll give us this nice color here. And that will actually apply along the material there. So if we then were to plug in into specular, Control W to duplicate, let's make it a non-rough, entirely shiny, so 0 to 1, remember. 1 shiny, specular, 0 rough. Look at that. We got a weird looking plastic. Let's make it 100% metal as well. You'll see what we get here. Let's delete all that. That's just the basics for materials. We have our empty carpet. Let's go ahead and get some textures to apply there. So in our browser here, we're going to open our Explorer and go to where some of those are. Let's find that. All right. So you can use JPEGs, PNG, Targa files, or Photoshop. Stay away from JPEGs as much as you can. Those are very compressed. But I am using these Targa files here. And I'm going to drag those in. We have diffuse, normal, and then roughness that we're going to use. So I just drag those in. Let's save all so we commit those to the project. Sometimes you may get these from like an interior designer, or you'll have to make these yourself in Photoshop and make sure they don't tile. You'll notice that our diffuse texture has some very basic values in here. I'm not sure about the tiling, but I guess we'll see here in a moment. Looks pretty good. The resolution for this is 640 by 640. Not great. I'd prefer if it was, up to like 2K or something, but we'll be fine. There's also this normal value, which again is explaining the direction that light is bouncing off of an object, and you'll see how that adds a sort of 3D look to it. You also notice that this is compressed differently. So this is set to normal map, which is vital for our normal values. And then we have our roughness channel. So this is actually 0 to 1 black to white value. We want to compress this differently. We want this to actually be grayscale here, and then change, let's see. Yes, here. Uncheck sRGB. So you'll notice that the resource size actually decreased as well because we're compressing it much more. There's less information being explained here because we really just want black to white. We don't want anything else, and you'll get much cleaner values if you choose linear like that. So now I'm going to drag that diffuse value in here, and I will drag that normal value into here, and that roughness value. So now you can see each of those has the texture here, and then we have this white as well as the red, green, blue, and then this is our alpha. This is the sum of all of those, so we're just going to plug that right into our base color, and you'll see right away we get that, that color on our material, and if we apply it here, we'll see it on the chair. It kind of looks like hot garbage, but we'll be able to clean that up here. Our roughness, you'll see this is actually set to linear, which is exactly what we want, and we'll plug that into our roughness. So what this is saying, where it is white, it is 100% rough. Where it is black, it is 0% rough. So now when you, let's see, look at this here, you can see some of these spots where it's darker, which correlates to, of course, this texture. Where it is darker, it is less rough. So we're getting some additional information in there. We'll have to clean it up so it looks less like, I don't know, wet carbon fiber. And then lastly, we have our normal value, which we're just going to plug right into the normal here. And then you'll see it actually adds some bumpiness to it. And if you look very carefully, it's not deforming the 3D geometry. It is still keeping those smooth lines for the sphere. It's just simulating 3D depth, similar to how a bump map would work, but not exactly the same. So if we were to apply everything, you'll see we get this really wet thing out here. We're not going to use this ultimately, but we're just going to show how to make your ArcViz materials here. Let's apply it to the sphere. Yeah, okay. So first of all, let's change the scale. So this is a nice node to remember. Right click and choose texture coordinate. And here we go. And what this gives us is a red and green gradient, essentially. And if we plug this into the UV coordinate, the UV input for each of those textures, we can use that to scale our value. So by default, it's 1 and 1. And remember, this is referring to the UV texture 2D image we had for each of those meshes. By default, it's set to 1 and 1. If we set this to 2 and 2, we'll see a completely different result. It'll actually scale it so it's much smaller. And if we do the inverse, obviously it would make it much bigger. And man, it's looking sort of like organic right there, like a alien something. Yeah, alien chair over here. Whew. All right. So we'll leave that alone for now, but let's talk about instances real quick. So as we make our materials for our scene, we'll probably want like 4 or 5 carpets or like 2 different kinds of metal or brick or something spread throughout our scene that that are very similar in values but have a few very, very different things. Maybe like the colors will be different, the roughness will be different. How do we make those so they're related but not identical? Let's select our carpet that we just made, and we'll right click it and we'll create material instance. And what that does is it makes an instance of that thing we just made, and we'll call this mi underscore carpet underscore 1. Oop. Nice spelling, Einstein. There we go. And we'll apply that to, let's apply it to the second sphere here. So if you notice this is m carpet, this is mi carpet 1. And if we were to change some of these values here, if we were to make this metal or something, it would apply to both because this instance, again, is inheriting from this m underscore carpet. But if we were to parameterize some of these options, we would be able to adjust those for the instance. So let's go ahead and let's make a constant 1. Oops. Just a constant here. Let's unplug, if you alt left click, unplug that base color, plug that in. So now this is going to be black. We still have that roughness applying and that normal, but this is just black color. So if we choose this now and convert to parameter, let's call this color, and save it. So we could set the slider minimum and maximum and the default value here. This will help us out in the instance. If we open that instance now, we have that color value. So if we were to move down here, drag that, it actually applies in real time in our editor. So this immediately probably gives you a few ideas of ways you could use this, right? So let's take it a step further. We have this grayish garbage. Let's Control W, duplicate this, and we'll have our MI Carpet 2. Drag that over there. Apply our MI Carpet 2. And now if we open that up, we could change this as well. So look, we have two different things inheriting from that same object, that same master material, but with entirely different results. So we don't want it to look like this flat thing. So we're just going to plug our texture right back in here. And then let's talk about what we can do with the scale here. So let's unplug those entirely, and let's save. And you'll see we get, this is green 100% to 0 and red 100% to 0. If we were to drag out here and let's type in mask, so you get this component mask. This is showing us you can mask out the red, green, blue, or alpha channels from whatever was plugged in. So here we have the same thing, but if we uncheck green, so we're just masking red, you get that 0 to 1, right? Same thing for green. If you do that, you get that vertical gradient as well. So with that in mind, seeing how that kind of comes together, let's drag out and do a multiply node. Okay. So then if we were to drag that into each of those UV inputs, we'd have this texture multiplying by 1. Remember, let's set that back to 1. It is our 1 and 1 multiplied by 1 gives us the size for these, which plugs into the color, roughness, and normal. If we were to then add a parameter, by default you can do a scalar parameter like we had before. Just hold S and click, and we'll do texture size. Perfect. By default, let's set that to 1 over here. And let's plug that into our multiply value, and we'll hit save. All right, here we go. And now if we're over here, let's take our carpet 1, check that value, and then we could scale that in real time if we needed to. Make it way too big, too small, whatever we want. Okay, so that's a good first step. Next, how do we move that texture without distorting the geometry in any way? So if we go add, take an add component, I'm going to hold left control and click and move those into there. So we're just keeping all of those. And I'm going to add another scalar material, or excuse me, scalar parameter. We'll do texture position. Okay. And let's set that to 0 by default, and we're just adding to those values without changing the scale of them. So if we were to, oh, you know what? That's not what I want to do at all. We want it to be two values. We want it to be one for the red and one for the green. So we're going to hold V for a vector value, which is going to get us red, green, blue, and alpha. And we will call this texture position again. And then we'll drag out of here. And we could mask our red and green. Or we could drag this out and append the green channel. And then we will plug that into our add. And again, this will allow us to just move it across the edge of the object without changing the scale. And one more thing, we could give ourselves the option in the future to actually rotate the material. So we'll go over here and type in custom rotator. And let's again move those into our rotated values at the end. Okay. And our UVs will come after our add. And how much of an angle do we want to rotate by? Let's make a scalar value, and we'll call this texture rotate. Plug that in here. And it's saying 0 to 1. So for our max value, we're going to say this can only go 0 to 1. By default, it's going to be at 0. Okay, and we'll save that. All right, so now if we have our materials out here, we see we could take our carpet 1 and we could go in here and we could move it along the red or the X or the Y for the green. And let's revert those back to 0 because we don't need them. For our rotation, we could actually spin it. Or for our size, we can make it bigger or smaller, whatever we want. Now, how would we use this for a practical purpose? Because this carpet does look pretty bad. Simply, if we take our texture sample here, and we'll right-click that, and we'll call that convert to parameter, and we'll call that diffuse texture. And we'll take this same thing, convert to parameter, and we'll call this roughness texture. And we'll take this one and normal texture. Okay, so a few considerations before we go any further. We're not going to worry about emissive. Specular, usually you want to keep that at 0.5, and we're not going to use this for metallic objects. Usually you just want something 0 to 1, or use a mask for metal, so we're not going to even worry about it right now. World position offset, we'll not worry about that. Ambient occlusion, we don't have a texture to work with right now, but if we had one, we could add another texture down here. Everything else that is masked out or grayed is something that we're not able to use with this material setup anyway. So we'll save that. And if we go over to our carpet now, we could actually change this with whatever we wanted. So we could make this brick. And then if you look over here, you have that brick with that same roughness input and normal input from the carpet. We'll just let this sit for now. We're not going to use that quite yet. So we'll delete these spheres, and let's make something that we actually will use. So I'm going to open this just for myself for reference. We'll make our own ceiling tile, and we want this to actually be dynamic and make it so we can use it going forward in a quick and easy fashion. So we'll call this M ceiling tile tutorial. Okay, and we'll save all. All right, and here we go. So let's pop that open, make it full screen over here. And base color for a ceiling tile, you guessed it, we want that to be 1. And let's just plug that into the base color. And then we want 2 texture samples. We want something to tell us where the bars are metal between the tiles, and then we want something to tell us the normal values to give us the perceived depth. So I'm going to go ahead and I already imported these textures, but I will find them in my scene. So I have this metal value and this normal value. I'll hopefully include this in the description if I can. So I'm going to go ahead and drag these into our material. And I'll show you how I have this set up. So our normal here, if we go put on this window, thank you. We have, you can see, we have these divots for those bars, but then we have these offsets and the noisiness for the detail, and then this metal. Remember, white is 1 and black is 0. So all those bars, those are 100% metal, and then you have some noisiness there, so we get some variety. And then black, we don't want the tiles themselves to be metal, obviously, so those are all blacked out. And those correlate. Obviously, they look like they would match together, so we'll plug this in well, we just want 1 value from this. By default, it would give us 4. So we'll just plug in the red. Same thing, it'd be 0 and then 100% for the white. Then plug that into the normal. Okay. And if we save this, you can see we get the metal there, and then the nice white bumpiness going on up there. All right. So if we were to add our texture coordinate and plug that into both of these values, make it not full screen, hit save. If we were to take this material and throw it on our ceiling. All right, we have some issues, right? So tiles would not would not look like that, where it's sliced across there, and then we wouldn't have it not going, so it's directly against the wall. ultimately we want to be able to move that positionally, like we were saying before with the X or the Y values. So we'll find a way to do that. Also, what if you just move or you change the mesh itself, right? Like if we had, let's say we took a plane out here and we wanted to add a material to it. Sometimes I like to make a plane for the whole ceiling and then just stretch it across the entire ceiling. But look at that. It stretches our material. That is bad. We don't want that. So here's what we'll do. We'll make it so our material actually, let's default it back to 1. For our material, so it actually uses the world space of the object itself, so it will stretch exactly how we want. So instead of using our texture coordinates to give us the UV coordinates for each of our textures, let's delete that. And let's type in world position. And by default, this is the absolute world position. You have some other options here, so you could do camera relative, but we're not going to worry about that. You could do some fun, funky shader things if you wanted to. So first things first, we'll mask out those red and green channels. So we're using the X and Y values. And then we want to do a multiply like we did before. Let's add a scalar for the tile size. There we go. And by default, we want that to be 1. Plug it into our multiply, and then take this, and you know what? Let's add that add and that rotator that we had before. That was pretty handy. So go over here, add, go over here, and we'll do a custom rotator as well. And if you remember, we had the tile position 0, 0, 0, and then the angle, so the tile rotation. This is a 0 to 1, 0 by default. Plug in there. Plug in our UVs. Circuit board is looking good. All right. Yeah, there we go. And if we look at our texture now, let's make this an instance so we can actually manipulate those in real time. Apply that here. Bring that guy over here. There we go. So if we were to change our tile size now, why is it not showing? Did we forget to plug something in? Mask. Tile position, tile size, tile rotation. Huh. Let's do some debugging here. See what's not working. Okay, so we have our metal there. Is our metal working? No. Our normal's not working either. Absolute world position, multiply by 1. Okay, we'll try skipping our rotator and our add and our scale as well. Just plug those values right in. Because it wants to mask those, okay. See, this is the important thing about not skipping ahead and cutting on the edit and everything. I want you to actually see how this plays out and how to debug. So we're masking, we're applying those to the UVs. Maybe we need a, let's try a cube and apply that there. Ah, do you see it? It is there. Yes, we do have our texture. It just looked solid white because it was so far away. So that's a no-no. So we'll backtrack a little bit. Let's plug that value back in. Plug that value back in. Let's take our world position, plug that into our mask. And our important value now is going to be that tile size because we saw that it was just not showing because it was so white. Yeah, you can kind of see it. It's very pixelated up there. So we'll go into our instance here. We'll turn that down to, let's say, 0.1. Okay, 0.01. There we go. We're getting closer. Let's do 0.002. Way too much. 0.008. 0.006. All right. Well, that's looking pretty good. And now you'll notice if we were to rotate this, let's make it a flat surface so it's 180 degrees. And now if I were to scale this object, see, it's not scaling our material. And if we move it, it's actually casting based on the world position of that object itself. And if I were to rotate it now, you'll see it's using that Y value, and it's only trying to cast on those flat surfaces. You can see this a little bit better with a sphere with that same material where it's rounded, and it'll look completely different from the side as opposed to the top. See how it's stretching over there. So that's a really neat trick for your ceiling tiles. We'll come back and maybe revisit that going forward, but personally, I don't think the values are currently spot on to get our 2x2 tile. I don't like that it's a solid gray up there, so we can change that as well. You know what? Let's do that now, actually. So we'll open our instance again, and we could actually, if we take our metal, remember it was black and white over here, we can use that to determine the color of our material. So if we were to, let's say we want the tiles to be white, so everything that's black we want to be white, everything that is white we want to be, let's say 0.5, and see how that looks. So let's drag out here, and we'll use a linear interpolator. So what this does is it gives us an A and B value. Think of a straight line A to B, and then your alpha is saying where along that line you are situated. We'll plug that into our base color. So now we're using that, remember, that white and that black. So the white being A, excuse me, the white being B, black 0 is A. So we want our 0 value to be, what did we say? We want the black to be white, so we'll keep that here. Okay, there we go. And we'll duplicate that, and we'll say 0.5 for the white value. Okay. And now if we save it, let's see what we get. We get nothing. Let's make these parameters. Let's call this diffuse B. Let's call this, oops. Let's call this diffuse A. Okay. And let's open up that instance one more time. So now we can actually change these in real time and see how they look. Okay, now we're talking. So if we were to keep that low, if we keep that 0, we could get completely black, which we don't want. Let's make that about 0.8. And then we could change the blackness to whiteness of that tile, but we'll want that white as well. I actually want that to be a little bit whiter. I don't like it that much. You know what our problem is? It's too much metal. Dare I say it, for the for those bars, but we'll come back to it. What we could do is use a linear interpolator. Let's do that real quick. Use a linear interpolator for our metal. So again, using that black and white value, and let's make one of them. Let's see. We want our white to be. Let's do 0.8. And do our other one 0, because again our tiles are 0 metal. I just broke one of my cardinal rules. You should only ever have a 0 to 1. Oh dear, a 0 to 1 metal value, and I just made a 0.8. This is one of those cases where you may want to break your own rules to make it actually dialed in a little bit. Let's try turning that down even further. Let's do 0.5 metal. And we'll see how that changes that bar. There we go. Let's try 0.2. Again, we want this to be more white, so it actually looks like yeah, so it looks like ceiling tiles would. Great. Okay.